Hello everyone. In this video, we will talk about the the hypothesis test for independence for categorical data. So this chi-square test procedure, well, it can also be used to test the hypothesis of independence of two variables of classification. Okay, so you have two variables and you want to test whether these variables are independent or not. What does it mean? Whether one of the variable affects the other or not. So this is a good example, I think. So suppose we want to determine whether being a fan of a team is dependent on the gender or not. So to do this, we just need the data about two variables and a random sample of residents from a region is drawn, and each resident is asked two questions. Well, what is your favorite team and what's your gender? So we have this table. Okay. So there are 336 many Galatasaray fans, 351 Fenerbahçe, 313 Beşiktaş. So total of 1,000 people are questioning, let's say. Well, you see that, well, among Galatasaray fans, 182 of them are male, 154 of them are female, and so on and so on. So what I'm interested in is that, well, whether the proportion of the males and females just differ in each team. For example, well, the proportion of, let's say, females, is it higher in Galatasaray when you just compared it the Beşiktaş? Okay, so this is our A. Okay, so this is what we call a contingency table. Okay, so the entries of this contingency table are in fact the observed frequencies, right? So we just observed 182 many males who are a fan of Galatasaray, or we observed 110 many females who are just fan of Beşiktaş. Okay, so these are the observed values. In other words, these are the OI values. So the thing is that how to calculate the expected values. So in general, in a contingency table, we have R rows and C columns. And the row and the column totals are called the marginal frequencies. So the row and the column totals, which are these, okay? So these are the marginal frequencies. So this is the marginal frequency of the teams, and these are the marginal frequencies of male and female. So remember, we have a kind of a distribution. We have a kind of this check when we just study the joint probability distributions in the probability class. Okay? So remember, we have the joint probability distribution table, and we just look at the table to see whether two random variables there are independent or not. Okay, so my hypothesis is, well, the two variables are independent of each other. Okay, so gender has no effect on the favorite team. And H1, well, the two variables are not independent. So they somehow related and they somehow affect each other. So what I do is, well, first, so I will try to calculate the expected frequencies, okay? Well, under H0, so don't forget this. So up to now, up to this lecture, since the beginning of our lecture, or let's say term at the beginning of summer. So when we are calculating, when we are just testing a hypothesis, what we do is we just assume H0 is true, okay? By assuming H0 is true, we just calculate the observed, let's say the observed random variables, and we are just able to find the probability distribution of the test statistics and so on and so on. So what we do is, to make a test, we first assume that, well, assume H0 is true. So we will calculate the expected frequencies under the assumption that H0 is true. Okay. So let me just define the events. So the events are, so let's say the event G is a person. You just select the person among this, let's say, crowd, among these people. And G is the event that he's a fan of Galatasaray. Okay. F is an event that you just randomly pick a guy and he's a fan of Fenerbahce. And B is the event of the selected person is a fan of Beşiktaş, right? And then I have another additional two events. M is, well, you just randomly select a guy, let's say, you just randomly select a person and he is a male. And E is, so F is reserved. I will just write F, but well, F is for Fenerbahce here. So E is, now you just randomly select a person and he is or she is a female, right? So these are the events. So what I will try to do is, remember, I will try to find the expected frequencies, okay? So what are the expected frequencies? Remember, how do we find it up to now? We just have the number of observations and times the probabilities. So, okay, what is the number of observations in our case? In our case, the number of observations is the number of people, right? So there are 1,000 many people in our crowd, in our, let's say, in our research group, 1,000 many people. Now, for example, assume that I will try to find what the males, okay, let's say this is the Galatasaray fan males. Okay? I will try to find this. Okay. Galatasaray fan males. How to find this? I need the probability of this. Okay? The probability. So the probability that I pick a guy from the, let's say, from the from thousand many people, and what is the probability that he is a Galatasaray fan and he is a male? Okay. So what is this event? This event is G, okay, being a Galatasaray fan. And what is this event? This is M, right? So I'm just asking, what is the probability of uh, G, what is the probability of occurring this event that I will define? G and M, okay? So what is the probability that G and M? So what is M in probability? It's intersection, right? G and M. So what is the probability that you have G and M? Well, recall that we assume H0 is true. So H0 is true says that, well, these two events are independent of each other, right? If they are independent of each other, then what is the probability of their intersection? It's simply their multiplication, right? Probability G times probability M. Okay. So probability of G times probability of M. This is the probability that you pick a guy from 1,000 many people, and the probability that he is a Galatasaray fan and he's a male, is equal to this. Okay. So the last point is, what is probability of G and what is probability of M? Well, that's the easiest part. Why? So just look at here. I have 1,000 many people here, okay? And 336 of these guys are Galatasaray. So what is the probability of G? Probability of G is equal to 336 divided by 1,000, okay? So the probability that a guy is a Galatasaray fan is simply the number of observed people who are Galatasaray fan divided by the total number of people. Okay? So how about Fenerbahce? This is equal to 351 divided by 1,000. How about Beşiktaş? That's equal to 313 divided by 1,000. Okay. And how about the probability of being a male? You just pick a guy from that crowd and it turns out that he's a male. 598 divided by 1,000, 402 divided by 1,000. Okay. So these are, again, these are the marginal frequencies, let's say. Not marginal frequencies, but these are the marginal probabilities. Okay. Now, once you have calculated this, so what is probability of you have a Galatasaray fan who is male? So this is equal to probability that G times probability of M, which is equal to, let's say 0.336 times what is M, 0.598. So this is the probability that you have a male who is a fan of Galatasaray. Okay. Then what is the expected value of this? So what is the expected frequency of this, let's say G and M? That's equal to 0.336, okay? times 0.598, which is the probability, times I have 1,000 many people here, times the probability here. That just gives you what? The expected frequency of these guys. Okay? A guy being a male and the galactrite fan. Okay. So, well, in the slides I have this as well. The probability of G is equal to the probability of G. Okay, so the probability of G is equal to what? This 336, right? I've just written here. Probability of F, probability of P, and so on and so forth. Okay. So GFN, FNM, FNA, and so on and so forth. So all these probabilities can be calculated by just multiplying two of them. Okay. 0.36, which is here. 0.598, which is here. And it turns out that the probability that a guy is a fan of Galasa is equal to 0.2. Okay. Okay. So in general, how can we just write the expected frequency in a contingency table is the column total, okay, times the row total divided by the grand total. Okay. So just go back here. So how do we find the expected values? So let me just write this. So for example, let's say the E of, let me just write it, G and M, that's equal to 336 divided by 1,000, okay, times 598 divided by 1,000, okay, so this is the probability, right? So this is the probability that you have a galactrite fan who is a male, times N, which is the grand total, so this is N. So these just cancel, hence this is equal to 336 times 598, okay, divided by 1,000, right? So this is exactly equal to the formula that it is given here. The column total times the row total divided by the grand total. Okay? Well, again, I will just find the chi-square. So this is my chi-square observed. It is greater than the chi-square critical, which is an area of alpha to the right. And what is the degrees of freedom? Well, the degrees of freedom is a bit different here. So what you do is you just multiply row minus 1 and column minus 1 here. So I have 2 rows and 3 columns, okay? So this is 2 times 1 times 2 minus 1 times 3 minus 1, which is equal to 3, in fact, right? So the chi-square, so this is my chi-square observed, 7.85, and the chi-square observed is equal to what? 5.99, okay? So it turns out that the chi-square observed is greater than 5.99, okay? So what does it mean? Well, okay. So we just reject the null hypothesis, okay? Now we reject the null hypothesis. So what does it mean, rejecting the null hypothesis? It means that, well, there is a dependence between the gender and the favorite team. Okay, so the gender affects the favorite team of a person. So this is our result. Okay.